Okay, we'll continue on with using stereolithography, and this time we'll be using acrylate. The particular study that I was looking at was that they were basically making super tiny needles that they were going to use to deposit chemicals into human skin. I called them microneedles, of course, because they're small. The specific goal they were having is they were trying to make needles as small as possible that could also just puncture the first layer of skin so that they wouldn't cause pain and that they'd actually go through the skin to be able to deposit the chemicals they were aiming for. They created the microneedles using microstereolithography, and they used acrylate, silver, and zinc oxide to eventually find the properties they were looking for. They deposited silver on one set and zinc oxide on the next set, and they were also trying to determine if they could actually decrease skin infections by having antimicrobial properties on the microneedles that they were printing. So this is one of the little scaffolds they were making. You notice the microneedles up there. That's one of the shapes they eventually determined would work fairly well. Whoop, too far. So first thing they were looking at is to see the resolution. If you can see these numbers, you can see that everything lines up fairly well with what they're aiming for. The heights that they were aiming for usually ended up a little bit lower, a lot lower in some cases than what they were aiming for. It's because they can't control the raising and lowering of the bed as accurately as we could hope for. But the input width and diameter all shrunk down a bit, which means that they're having issues keeping it small because the cured photopolymer actually reacts differently to light than non-cured, so it can actually shrink in that plane. So everything ended up well enough that they moved on to the next step, and they deposited silver on one and zinc on another, and the method they used, lasers, pretty much laser gasification. They did this at a near absolute zero pressure so that they could do it at a low temperature so they wouldn't actually melt photopolymer. But you can see right here, over in the left graph, where the arrows are pointing, they actually did a dye penetrant test with the needles on pork skin to determine if dye actually made it through the skin. And you can see by those arrows, it was blue in the original photo, but it didn't come out blue in the actual report. So the dye actually did penetrate just through that first layer of skin, as they were hoping for. And if you look over here on the right, you can see some culture tests using E. coli and two types of staph infections. So at the top is the E. coli. There were no significant effects, so it wasn't entirely effective against it. But in the two staph infections, there were actual dead zones around it, proving that it did have antimicrobial effects. So, summary of this, it's a fairly effective way to create microneedles. The resolution's just about perfect for what they're aiming for, and silver and zinc oxide are fairly effective methods of treating skin infection. My personal critique was that the paper was kind of out of order in places. They went through all of the methods they used to create it in a row and then told the results. It would have been nice to have those split up so that they tell you the method and then the result of that particular test. And they also did not offer nearly enough explanation on how they got the results for the microbial tests. They just said that this one had an effect and this one didn't.